x and another cos here x. This sine and a cos will give us tan, which also gives us 2 tan x. All right, guys, now let's have a look at question 5 of 2024 past paper on trigonometry. This was a Limpopo paper. I believe this was out of 3 marks, and then also this year was also out of 3 marks. It says here, let's have a look at the question. It said, if tan 35 is equal to m, determine the value of the following in terms of m. All right, this is simply the same way as they would ask you in other question papers. They will say if you are using, also they will say with an aid of a diagram as well. All right, so now let's have a look at this one here. Tan, what you want to do first is you want to unpack this. Let's look at this here, which is tan 35. 35 is supposed to be our angle. It's equal to m. The trick here is that for you to recognize that, guys, this is all over 1. So, but we know that tan, it is what? It is opposite over adjacent. All right, if you remember from SOHCAHTOA, which is also by over x. Right, so let's go ahead and draw the diagram and try to answer this. I'm just gonna put my diagram here. Okay, there you go. That is x. No, sorry, this is y. This is y. Therefore, this is our x here. All right, so therefore this is y, so it means 35 is here. That's our angle. And then therefore this is y, it's m. Okay, y over adjacent, this is 1, so therefore r is unknown, so therefore we are going to have to look for r in this case. So what do? We're going to apply Pythagoras theorem, which states that x squared plus y squared is equals to r. Is equals to r squared. Okay, we already know what is x. X is 1 squared. 1 squared plus y is m squared. It's equals to r squared. All right, therefore if you were to solve this, we are going to have r is equals to m squared plus 1, and then this is squared here. We take a square root on both sides, guys. I'm trying to be as basic as I can be so that you guys can follow. That's equals to m squared plus, my pen is not writing the best way I would like it to, but it's fine. There you go. So therefore our r here is going to be equals to m squared plus 1. All right, so now let's come here. If you have a look at here, we have got they are saying that we need to determine the following. So therefore 5.1.1, it's sine 215. All right, I've got a very nice way of simplifying this, guys. You have to remember this here as well, which is our Cartesian plane. We have to remember this as our Cartesian plane. Here it's 180 plus theta. Here it's 180 minus theta. Therefore here is 360 minus theta. Guys, you must know this by head, please. You must know this by head. All right, so now where is okay, here it's 90, here is 180, there is 270. All right, so now guys, using your Cartesian plane, where is this 215? It's here on third quadrant. Third quadrant is symbolized by 180 plus. Therefore here you would say equal to sine 180 plus something else must give us 215. 180 plus happens to be 35. Make life easy for yourself, guys. Sine 180 plus 35 gives us sine 215. All right, so therefore it's sine positive here or negative. It is negative, so it means now on our equation you're going to be left with sine negative sine 35 degrees. negative sine 35 degrees. So therefore, what is sine? Sine is opposite over hypotenuse, so it means here you are going to have negative. Opposite is m over hypotenuse, which is square root of m squared plus 1. All right, I think that is simple and straightforward, guys. If you've got a question, please leave it in the comment section below if you still don't understand. All right, let's go to 1.1.2. 1.1.2 says that sine 70, as you can see, 70 is twice as much as sine 35, so therefore it's going to be sine 2 times 35. 2 times 35, guys. And then if we were to simplify this, you remember from the identities is going to be 2 sine 35 multiplied by cos 35 as well. All right, guys. Okay, now we can just substitute. We already know what is a sine 35, so 2 will remain as 2. Sine 35 is opposite over hypotenuse, which is positive here. Here it's not negative, guys, because sine 70 it's here on the first quadrant, so everything here will have to be positive. All right, and then we've got cos, which is adjacent. Adjacent is 1 all over hypotenuse, which happens to be squared. It's going to be plus 1. Close bracket. All right, let's see if we can simplify this further, guys. We're gonna multiply 2 multiplied by m multiplied by 1 is going to give us 2m on the numerator. Is going to give us 2m all over square root of m squared plus 1 times square root of m squared. The square root will fly off, therefore you're going to have m squared plus 1 as our answer. All right, and that's how you would deal with 5.1. Let's move on to 5.2. Okay, 5.2 says tan alpha is equals to 1 over 3, and then also tan beta is 1 over 7, where theta and beta are acute angles. Determine the value of 50 times sine 2 alpha times beta. All right, guys, the best thing to do here, you would know that tan, let me work it out here for a little bit. They already given us tan alpha is equals to 1 over 3. So on this one, guys, you can use a diagram, okay, so that you can see your stuff properly. Let's presume that this is alpha. So this is what? Opposite over adjacent. So opposite is 1 over adjacent, which is 3 here. Same thing would apply with the other one of beta. Tan beta is equals to opposite over adjacent. Okay, so now let's do the same thing here. The same thing would apply here. There you go. That's angle beta here. Opposite it's 1, adjacent it's equal to 7. All right, so now with this, what you can do, you have to look for the hypotenuse in all of them, which is something that we did on the previous example, guys. I'm not going to show that here as well. So the best thing to do is to use Pythagoras theorem, which states that x squared plus y squared is equal to, in fact, let me just do 1 is equals to r squared. So let's do this one here. We're going to substitute x is equals to 3 squared. X is equals to 3 squared plus 1 squared is equal to r squared. So therefore we are going to have r is equals to 9 squared is equals to 9. 9 plus 1 is equals to 10. Therefore our answer will be square root of 10. So now our r here will be square root of 10. Makes sense. Same thing would apply here. 7 squared is equals to 14. 14 plus 1, 7 squared is equals to 49. For this one, 49 plus 1 is equals to 50. So therefore our r in this case will be square root of 50. All right, guys. Okay, so now when we come here, we need to simplify this. If we go and check on your on your formula sheet, you will have to find a way to simplify this. There's somewhere where they wrote for us sine A plus B, it's equals to da 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 da. They wrote something there. So same thing applies here. If we think that this is A plus B, we need to expand it the same way. So let's come here. So it's going to be let's come here. It's going to be 50. Okay, I think we're gonna leave 50 out of the bracket as it is now. So it's 50 times sine, let me just write it down here properly, plus beta. Okay, all right, there you go. So if you come here, you're going to say sine, leave this one out of the bracket, so sine 2 alpha is gonna be times cos beta plus in this case cos 2 alpha times sine beta, therefore close bracket, sine beta, then you close the bracket here. Here we go. All right, so as you can see here, we've got two identities here. We've got this one sine 2 and also cos 2, so therefore we need to simplify these two here. So sine 50 is going to give us equal to, put this in the square bracket. This one, when you simplify, is going to give us 2 sine alpha cos alpha times this cos beta that is there, cos beta, plus this one here, cos 2 alpha. We're going to simplify it as we check on our formula sheet. We see that there's cos squared alpha minus 1 in all brackets times sine beta that is sitting there, therefore close bracket. All right, so now what we can do now, as it is here, what we can do, we can simplify this going further. We have to simplify this now, or we can now substitute as it is. Guys, either way, what we're doing here now is just algebra, so I rather prefer that we substitute straight away. Sine alpha here, sine alpha will be from this one is going to be opposite over hypotenuse, or opposite over hypotenuse. There you go. So we dealt with this one. Cos alpha is going to be adjacent, which is 3 here over hypotenuse there. Okay, so it's 3 over hypotenuse, close bracket, therefore alpha, beta, cos beta is from here, is going to be adjacent over hypotenuse. Adjacent in the other triangle, it's 7 over root 50, close bracket, plus, in this case we have got 2 here, alpha cos squared alpha. So what is cos squared alpha? Is 3 over root 10, but needs to be squared, therefore we also minus 1 from this as well. Then everything that is here, guys, be careful with the brackets, also need to be multiplied by sine beta. Sine beta is going to be 1 over square root of 50, therefore square bracket. All right, so as it is now, guys, you can simplify, do the algebra, make sure that the math is matching, and then do all the necessary things. I have punched this already into my calculator, guys. You can do it step by step. There is no need to rush, but I have put everything all together here for the sake of the video, so that the video doesn't become too long. So if you manage to get to this point, well done. It's great. I think this question was out of 6 marks. This question was out of 6 marks, so please make sure that you take a time and make sure that you fully understand this one, because it's worth a lot of marks. So the answer that I've arrived to is 25 square root of 2. So please let me know what you think on the comment section below, guys. If you get it, please give this video a huge thumbs up. If you don't understand, please let me know on the comment section below. Let's move on to 5.3. Now 5.3 is a simplify question. Just normally they will say simplify. This is known as reduction. So you simplify without the use of the calculator. So let's go ahead and have a look at this one here now. They are given their cos 180 what. So now in this case, guys, you must always remember your Cartesian plane. 180 minus x, 180 plus x, 360 minus x, this is negative x, and then this is all here. They are positive, sine and tan. So please, guys, you need to remember this Cartesian plane. By all means, guys, please make sure that you fully understand this one. You fully remember it. And also, you must also know your core angles, for that when it's 90 plus or 90 minus, it changes the angle. Please have a look at our video on lesson on trigonometry or on reduction. So we're just going to come here and simplify this. Cos minus x, this one is on the fourth quadrant, this one is on the fourth quadrant, therefore this will just remain. Cos is positive there, though it will stay like that. Tan 180 minus x, this one will be negative tan because it's in the second quadrant. Tan is negative here, therefore here we go. We have got now a 90 minus or plus. First thing you need to understand here is that it's going to change and become sine, but is it positive or negative? In this case is going to be positive because 90 minus is sitting on the first quadrant. On the first quadrant we've got 90 minus x, here we have got 90 plus x. All right, so therefore it's going to be positive like that. Therefore we've got 180 plus. All right, guys, normally on this one I would advise my learners to always say if you've got a number that is above 360, you must minus 360 from that number to make life easy for yourself. Or for those who can read it directly, you can try to do that. It's not a problem, but I always advise that you minus 360 from it first. So let's have a look at if you say 540 minus 360, how much are you left with? Say, okay, let's see now. 540 minus 360, you are left with 180. So basically this thing can also be written as 180 plus x, this one here. So you see, guys, that's why I'm saying, oh, sorry about that, that's why I'm saying if you minus 360 from it, you make life easy for yourself. So sine 180 plus, what does that mean? Sine 180 plus is going to be negative. Sine is on the third quadrant, so sine will be negative here. All right, then we've got sine 180 minus is going to be positive sine here. All right, so now we simplified everything. The next thing that is left now is just algebra. All right, let's go. We have got here at the top here, sine, negative sine and negative sine would cancel out. What do we have here? We have got cos x, and then tan is also sine over cos x multiplied by sine x here. Cos x and cos x would cancel out. Sine and sine at the bottom, we can also cancel out with another sine here. This sine would cancel with this sine here. This sine would cancel with this sine here. Our answer, we're left with 1. All right, so you could have cancelled differently, really doesn't matter, guys, as long as you get a solution of 1. The most important thing was to reduce here, reduction angles, reduce your ratios, and then make sure that you get to the right answer. Let's move on to 5.4. 5.4, it's an identity. It says here that to prove that, okay, 5.4.1, it says that prove that sine over 1 minus sine plus sine over 1 plus sine is equals to 2 tan x divided by cos. All right, so let's come here. You know what to do, guys. We'll see from the left hand side when it comes to the identities. So sine x plus sine x all over 1 plus sine x all over 1 minus sine x. Great stuff. Let's go. All right, so now here, what do we say? We look for an LCD because we've got a fraction. 1 minus sine, LCD refers to the everything that is at the bottom. 1 plus sine x. So therefore 1 minus sine x will go 1 plus x. So it's going to be sine, the one at the numerator, multiplied by 1 plus sine x, all close bracket, plus sine x, close. Therefore 1 minus sine x. Great. So now what we can do now, we just need to remove the bracket here. Okay, first thing first, we're gonna remove the bracket here. Sine will multiply with sine times 1 is going to be 1, plus sine times sine is going to be sine squared x, plus sine times 1 will going to be sine. I'm multiplying here, guys. Okay, negative sine times sine will going to be negative sine squared. Therefore 1 minus sine x, close. Therefore close here, 1 plus sine x. All right, what do we have at the top? We've got plus sine squared and then minus sine squared. This would cancel out, and then therefore what are we going to be left with? We are going to be left with sine plus sine is going to give us 2 sine x, right? So if you have a look at the bottom, if you were to remove the bracket at the bottom, we are going to be left with 1 minus sine squared x. If you remove the brackets at the bottom, guys, I already did it because you can already see that this is the difference between two squares, and we know from identities that this 1 minus sine squared x is also equals to cos squared x. All right, and then therefore if you have a look at this one, you can also separate the cos at the bottom, which is 2 sine. If you say 2 sine x all over cos here x and another cos here x, this sine and a cos will give us tan, which also gives us 2 tan x divided by cos, which is also equals to the right hand side. Okay, so that's how you would deal with a question like this one, guys. If you've got any questions, please let me know on the comment section below. And then let's move on to 5.4.2. 5.2 says for values, for which values of x between 0 and 180 will the identity in 5, okay, they wanted to say in 5.4.1 not be defined. All right, so this is the situation where this will be undefined. Okay, so basically it will be undefined. This is a situation where you would know, guys, when it comes to tan it's undefined when when x is equals to 90, you'll get an error, and also when x is equals to 270. As simple as that, guys. Please let me know what you think. If you think I made a mistake somewhere, please let me know. And if you really enjoyed this video, let's give this video a huge thumbs up so that it can reach as many people as possible. This was from a past paper, I think, Limpopo past paper. Yes, paper 2, question 5. Let me see you on the next upload. I am Gastin Mapala. See you then.